Today's lesson is about solving nonlinear systems of equations. You've already learned how to solve linear systems of equations. That's where you have two equations that can be represented by lines, and you can either solve by substitution, elimination, or by graphing. And we're going to use some of those same techniques in this section. Our first example, we've got x squared plus y squared equals 25, and x minus y equals 1, and then we're asked to solve algebraically. While solving algebraically, sometimes you can use substitution and sometimes you can use elimination. The technique I'm going to use here is substitution. I'm going to choose to isolate one of these two variables, either x or y. It doesn't matter which one you choose. If I think about adding y to the other side, that gives me x equals y plus 1. Now I have an expression that can represent x, and I can take this top equation and substitute y plus 1 in for x. So that will look like y plus 1 quantity squared plus y squared equals 25. Now I'm going to take this expression and I'm going to move it down here to start to simplify. Y plus 1 squared, we can think about multiplying y plus 1 times y plus 1 and distributing. That will give us y squared plus 2y plus 1 if we FOIL that out. And we still have plus y squared equals 25. Now we can combine like terms. Y squared and y squared is 2y squared plus 2y. And I'm going to think about subtracting over the 25. If I subtract 25 here, I can combine a negative 25 with a positive 1 and get negative 24. Now I'm left with a quadratic equation to solve. I set it equal to 0 because you always want to start by trying to solve by factoring. If factoring doesn't work, you can try the quadratic formula. First, I noticed that every term is even, so I can start by just dividing everything in the whole entire equation by 2. That's y squared plus 1y minus 12 equals 0. And now I've got a nice, easy trinomial that I can factor. Y squared comes from y times y, and numbers that multiply to give negative 12 and add to give positive 1, it would be 4 and 3, positive 4 and negative 3, and so we get y equals negative 4 and y equals positive 3. Well, this isn't our final solution because our goal is to solve the system, and the system involves both x's and y's. So we can go back to any equation in the beginning to figure out what y is for each, to figure out what x is for each of these y values. So I'm going to think about my solutions being coordinate pairs. If the y value is negative 4, now I need to find the x value. Well, I'm going to use this equation right here, this x equals y plus 1. X equals negative 4 plus 1, x would be negative 3. So negative 3, negative 4 is one of our solutions. We also have another solution for when y is 3. So again, thinking about my solution being a coordinate pair, when y is 3, let's figure out what x is. X equals y plus 1, so x equals 3 plus 1, so x equals 4, 4, 3 is the other solution. So we've got two coordinate pairs as solutions to this system. We can think about that exact same example and we can solve it in a different way. We can solve by graphing. Well, this first equation, x squared plus y squared, is the general form of an equation of a circle. The circle has the center 0, 0, and r squared is 25, which means the radius is 5. So if I start at 0, 0 and I think about a radius 5, here's what the circle would look like. And we can also think about graphing this equation, x minus y equals 1. Well, I'm going to take that x minus y equals 1 and think about writing it in y equals mx plus b form. So x minus y equals 1. If we subtract the x, that would be negative x plus 1, and then divide through by a negative, that would be positive x minus 1. So the line y equals positive x minus 1 has a y-intercept of -1 and a slope of +1. So rise, run, 1, run.